keep rolling. Okay, so you're in your booklet now, you're on 4.3. Okay. So we're going to use exact. Okay. Ladies and gentlemen, I gotta say I'm struggling a little bit today because this stuff is hard, and the first thing you're gonna say to me is this is too much and I don't understand. Right? Like that's gonna be your go-to line, and I'm trying to break it down into little pieces, but we're all off doing our own thing. And I think that maybe we're not doing our own thing when it comes to the unit circle. I think we're doing other things. But we're going to get this, and it does take some practice. So if you feel like it doesn't make sense right now, we just got to work with it a little bit. Okay, so we're going to use special triangles to find the coordinates of the points on the unit circle. And why do we call it a unit circle? What's the radius of it? 1 unit. So that's why we call it a unit circle, because it has a radius of 1 unit. What? That's why we call it a unit circle. That's why it has the name unit circle. It's because it has a radius of 1. What's its diameter if it has a radius of 1? Right? Okay. So what I want you to do is I want you to draw me an equilateral triangle with side lengths of 1 unit. Okay. Just do... What is equal? Okay, let's start there. They're all equal, right? So if all the sides are equal, what are my angles equal to? 45. Thank you. Woo! That was tough. Okay, let's back the bus up a little bit. What do interior angles of a triangle add up to? 180. And how many angles are inside a triangle? 3. Okay. So what? Each angle is going to equal 60. What's that as a radian? Pi over 3. Pi over 3? Yeah. Just let me slide this over. Oh yeah, but you can just times 60 by... You totally can, 100%, yeah. You totally can do that. You can do the conversion if you want. Okay? All right. Okay. So if I draw an equilateral triangle, and if I draw a vertical height in, so these all have a measurement of 1. You guys with me? So I'm going to draw in a vertical height. So what does that measurement make? I just drew it in, 90 degrees, right? What does this angle turn into? 30, yes. Okay. If this was 1, what's this? Half. So proud of you guys. So all I'm looking at is this half of our equilateral triangle. Okay, everybody good with that? Okay, now we're going to do trig ratios. Oh, we actually have to remember this? Got to dig deep. They're on the back wall. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. SOHCAHTOA. All right. There's one piece of information missing, though. There's one piece of information missing. What is missing from my yellow triangle? No, I have my hypotenuse. The height that we just drew in there. So without a calculator, Without a calculator, can you calculate the height? Yes, you can.
Okay.
What do you have to do? Pythagorean theorem is what we're going to do. Okay, all right. So we have
1.25?
a squared plus b squared equals c squared. We know what c squared is.
1/2 squared is 0.25.
Okay, so let's keep it in fractions though.
Okay.
So we have 1/2 squared plus b squared equals 1 squared. All right, you all good with that? Okay, so we're going to have 1/4 plus b squared equals 1. So b squared is equal to 3/4. Do I want b squared? I got to square root him. So b is equal to, can I take the square root of 3 nicely? So we're going to leave it as root 3. Can I take the square root of 4 nicely? So we're going to do that. It's amazing. So what you've just done here, ladies and gentlemen, is you have found the exact value. And the reason why we call it exact value is because we didn't have to round anything. We left it as a root 3. Make sense to everybody? Okay, so we know that this height is root 3/2. You just found that using Pythagorean theorem. Okay, now we're going to dig deep and we're going to do sine of 60 degrees, but let's put it as a radian for funsies. Sine of pi over 3. So sine of pi over 3 is the opposite side divided by the hypotenuse. So here's my angle, 60. So it's going to be my opposite side, so root 3/2 divided by the hypotenuse, which is 1. What does that simplify to? Root 3/2, right? Anything divided by 1 is going to be itself. Okay, good job, everybody. Good job. Okay, now we're going to do cosine. Cosine of pi over 3. Adjacent is the half, and it's divided by 1. So cos of pi over 3 is half. Let me just put boxes around these. Oh, I'm so gonna, okay, we're gonna run out of room. We might need an extra page. Okay. Oh no, because we're not done. What am I going to next? Tan of pi over 3 is equal to the opposite side, root 3/2, and it's going to be divided by the adjacent side, which is 1/2. Is it okay that I wrote it instead of like a fraction and a fraction, I wrote it as a division? To me, it makes it easier what math we're doing. Do we ever divide fractions? Multiply by the reciprocal. I don't know what's happening here. So we're going to have tan pi over 3 is equal to root 3/2 times 2/1. So that will cancel that. So tan of pi over 3 is equal to root 3. That's so exciting. Okay. All right, I'm switching colors, and we're going to do the exact same thing, ladies and gentlemen, with 30 degrees. Well, what angles did we put together on this one? We put the 30 and 60 because there's a relationship between them, right? So we found the exact values for 60 degrees. Now we have to find the exact values for 30. And then guess what we're going to do after that? 45s, right? All right. Maybe you could use the answer key, like down here. Maybe. Okay. All right. Here we go. We're going to do it for 30 degrees. What's 30 degrees as a radian? Pi over 6. So 30 degrees equals pi over 6. All right, here we go. So sine of pi over 6. Are you mocking me, Danica? Wow.
Yeah, I'm not proud.
I don't think that takes away from. Okay, pi over 6. So sine is going to be opposite this time, divided by the hypotenuse, which is 1. Is it okay if we jump right to the answer of 1/2?
Yep.
Well, what's 1/2 divided by 1? It's just itself, right? Okay. Cos of pi over 6 is going to be the adjacent side divided by 1. So that one's going to be root 3 over 2. Okay, now tan, I'm going to actually have to do some math here. Okay, tan is opposite over adjacent, so 1/2 divided by root 3 over 2. So we're going to have 1/2 times 2 over root 3. Those 2's cancel each other out. It's going to be 1 over root 3. Okay. Yep. The sine one? Well, so if we're using the 30 degree here in our triangle, the opposite side now has moved to the 1/2. 1/2 divided by the hypotenuse is going to be the 1/2. What's wrong? This one? Yeah? This one?
Oh wait, no, I got it. I was looking at the other one.
Okay.
Can we look at tests already?
No, because I still have Nicole who has to write.
Like,
Can you make the marks available? So that
Oh my gosh. I just want, you guys are going to be the first people to tell me you don't get this. Can we at least focus on this lesson first? I love you all, but you guys are butterflies. Okay, draw an isosceles triangle with legs measuring 1 unit. What's an isosceles? What's an isosceles triangle?
2 sides equal, 1 side not.
2 sides equal. Okay, this one might be a little bit trickier. Like, the equal one is kind of nice. Oh, that's not the binder I wanted. Raiden, are you okay? You sure?
Yeah, I'm good. I'm gonna go now.
You're leaving?
Yep.
Wow, are you sure?
Positive.
Okay. What did you do to him? Okay.
Thank you.
Bye. Okay. This is going to make more sense if I draw it better. No, it was not. That's why I let it go. Okay, so what do we know about the other 2 angles in the triangle? They have to be equal because it's an isosceles. And they have to be 45. Okay, and what is 45 as a radian? Pi over 4. Okay. They're equivalent. So 45 and pi over 4. All right. How do we find the measure of that side without using a calculator? Pythagorean theorem again. It's not. Right? Because you don't have the pi. It's not. Still not 4. Still not 4.
Okay, square root of 2.
Okay, all right, all right. And again, root 2 isn't a nice number to square root, so we're just going to leave it as root 2. So we know that the hypotenuse is 2, or root 2, sorry. Okay, let's do sine of pi over 4.
If it asks for the exact trig value, you do this sine, cosine.
Yeah. So sine of pi over 4 is, so let's use this one. Sine is opposite over hypotenuse. So opposite over hypotenuse. So 1 over root 2. Okay, we'll have to come back and talk about that in a second. Cos of pi over 4. What's the adjacent side? Still 1. What's the hypotenuse? Still root 2. Okay, let's do tan. I'm going to let you guys figure out tan all by yourself.
Oh, that's awful. Why would you do that to us?
Opposite. Opposite is 1. Divided by the adjacent, which is also 1, is 1. Okay, we're going to dig deep. We're going to go back to grade 11. And I'm going to ask you to rationalize this denominator.
That's in that calculus question that you physically created.
What? No, you were, oh yes, you were rationalizing the denominator by using the conjugate.
I don't fully understand how that works. We have
Okay.
to talk about that.
Is that where we like put them in groups?
No, that's where we get the radical off the bottom. Do you guys remember that?
Oh, yeah.
Right? And it's a single one, so I'm going to just pop to a different page. So if I have 1 over root 2, how do I get rid of root 2 on the bottom? Times it by root 2. But we don't want to change the value of the fraction, so we have to do it top and bottom. So this is going to be root 2 over root 4. What's the square root of 4? 2. So root 2 over 2. Well, okay, let's go back to the circle. Root 2 over 2 you're going to see on your circle. Just trying to link things together, trying to make connections. I love it. Bless you. Okay, so what you guys just found were all the exact values of the coordinates of the unit circle. Okay, so you're going to keep this page close. Okay, so this is what I need you to know, ladies and gentlemen. For that one, yes. No. Okay, I want you guys to go back to this page. We're going to put them in now. This is set 1, or the set without a number on it, and it was just the one we put the angles in. It's the third page, it's the last page. Okay. All right. So what you need to know about coordinate pairs is that x, y can be replaced with cos theta sine theta. Oh, sorry. I just realized that. So what you need in front of you is this. You need that off to the side for right now. Okay, you need this off to the side. And we're going to start filling in values on here. Okay, so the coordinate, instead of writing it x, y, we're going to write it as the cos of the angle and then sine of the angle. Everybody with me so far here? Now in quadrant 1, my x is positive and my y is positive. So we have to be cognizant. We got to remember that. Okay. Whew, we might not get through all. We'll get through this. Okay, pi over 6. So I'm going to this. And at pi over 6, what comes first? Cosine. So what's my coordinate of the first one? Root 3 over 2. So this is going to be root 3 over 2. And then sine comes next. So that's going to be 1/2. And is it okay if we do the 30s and 60s first? And then we'll go back and do the 45s? Just because the 30s and 60s are connected. Okay, so now we're at pi over 3. So we're in the purple numbers here. So cos is going to be 1/2. And sine is root 3 over 2. Okay. Okay. Oh, I guess we should do the coordinate of 90 degrees. What's the coordinate of 90 degrees? First of all, what's this length right here? 1. So if this is my y-axis and this point is at 1, what's the coordinate? Okay. All right, now let's talk about the x and y values in quadrant 2. X's are negative. Okay, so things change. So notice, ladies and gentlemen, I have a denominator of 3 now. Nowhere in our notes did we do anything with 2/3 pi. We didn't do anything with that. But it's the same rules that apply. Okay, I'm going to draw a triangle on here. Please only follow if you need to. If I draw this triangle on in red, okay. So do you guys see that 90-degree triangle there that you guys see it? Sort of, kind of? So what's the y value here? It's a tall triangle. What's the y value? Root 3 over 2. So the height of this triangle is root 3 over 2. What's the base of this triangle? 1/2. Okay? What's the hypotenuse of that triangle? It's just 1, which if you did a squared plus b squared, you will get 1. Well, because I know it's the radius of the unit circle is 1. We can calculate it out if we need to, but I don't think we have time. Okay, so if we go over to this point here, and I draw in the triangle again, what do you notice about the height of this triangle? It's the same as this one, right? You guys would agree? So this one is root 3 over 2. What's the base of this one? Okay, so now I'm in quadrant 2, so the x value is going to be that negative 1/2. So what's the coordinate pair for 2 pi over 3? Negative 1/2 and root 3 over 2. So what you're going to find is that all the angles with denominators of 3 are going to have this coordinate pair, but the sign will change based on where you are on the quadrants. So if we go back down to 4 pi over 3, right, because this has a denominator of 3, this one has a denominator of 3. If we go back down, look at this triangle that I'm drawing in here. What's the height? Now we're going down, so it's going to be a negative 3 pi over 2. My base is negative 1/2, so this would be negative. So there's your x value. There's your y value. So this one's going to be negative 1/2 and negative 3 pi over 2. So knowing that information, what's 5 pi over 3? Sorry, there is a negative there. It's just really hard to see. So 5 pi over 3 is going to be, nice, positive 1/2, negative root 3 over 2. So the positive negatives will change based on where you are, if you're in quadrant 1, 2, or 3. Make sense? Okay, so now denominators of 6's. Denominators of 6's. So if I look at this one, it's going to be a short y this time, but a long x. So root 3 over 2, 1/2. If I do that same thing over here, if I draw in that triangle, I get that short y and that long x. But now my x's are
So negative.
negative root 3 over 2, positive 1/2. Okay, quickly fill in your denominators of 6's. Yes, you can. It's the exact same coordinate pair, but the signs will change. What are the signs going to be in quadrant 3? Negative, negative, because the x and y are both negative here.
Wait, quadrant 4,
Mm-hmm.
it's gonna be a positive 1/2, but a negative.
No, we're doing 6's now, so you should be a positive root 3 over 2. But yeah, a positive and then a negative. I always think about the short longs and the long shorts, like, okay, so we're gonna leave it here for today, and we'll finish up our 4's, like our denominator of 4's tomorrow.